Hello everyone. Welcome back to topic 5, Deep Learning for Natural Language Processing. In this session, we are going to talk about bag-of-words model. The bag-of-words model is a way of representing text data when modeling text with machine learning algorithms. The bag-of-words model is simple to understand and implement, and has seen great success in problems such as language modeling and document classification. For neural network and traditional machine learning models, they require their input in vectors or tensors whose elements are in numerical form. So how is data presented in this form of text fed as input to such a neural network model? One of the methods which enable us to do this, and we will discuss below, is called one-hot encoding. In one-hot encoding, every word or every token are part of the given text are written in the form of vectors, constituting only of ones and zeros. So one-hot vector is a vector whose elements only have 1 and 0. Each word is written or encoded as one-hot vector, with each one-hot vector being unique. This allows the word to be identified uniquely by its one-hot vector and vice versa. That is, no two words will have the same one-hot vector representation. For example, we are doing one-hot encoding of two words, motel and hotel, within a sentence. One word is represented as a vector. Therefore, the list of words in the sentence can be represented as an array of vectors or matrix. And if we have lists of sentences whose words are one-hot encoded, then it will result in an array whose elements are matrices. So we end up with a three-dimensional tensor, which can be fed to the neural network. However, there are also some drawbacks of one-hot encoding method. The dimension of the vector is depending on the vocabulary size. The larger the vocabulary, the larger the vector size. And this can lead to memory problems. Besides the potential memory capacity issues, another major drawback of one-hot encoding is the lack of meaning representation. While we capture the presence or absence of words in a particular text, with this approach, we can't easily determine any meaning from simple presence, absence of these words. Part of this problem is that we lose positional relationship between words or word order using one-hot encoding. This order ends up being paramount in representing meaning in words. The bag-of-words model is a way of representing text data when modeling text with machine learning algorithms. The bag-of-words model is simple to understand and implement and has seen a lot of success in problems such as language modeling and document classification. The bag-of-words model is a simplifying representation used in natural language processing and information retrieval. In this model, a text, such as a sentence or a document, is represented as the bag of its words, disregarding grammar or even word order, but keeping multiplicity. The bag-of-words model has also been used for computer vision. In technical terms, we can say that it is a method of feature extraction with text data. This approach is simple and flexible way of extracting feature from documents. A bag of words is a representation of text that describes the occurrence of words within a document. We just keep track of word counts and disregard the grammatical details and the word order. It is called a bag of words because any information about the order or structure of words in the document is discarded. The model is only concerned with whether no words occur in the document, not where in the document. So, why do we use bag of words model to represent text? One of the biggest problems with text is that it is messy and unstructured, and machine learning algorithms prefer structure, well-defined fixed-length input. And by using the bag of words technique, we can convert variable length text into a fixed length vector. Also, at a much granular level, the machine learning model works with numerical data rather than textual data. So, to be more specific, by using the bag of words technique, we convert a text into its equivalent vector of numbers. Let's take a look at an example how we can implement the bag of words model. Suppose we have two sentences to be vectorized. First sentence, student learn NLP and like NLP. The second sentence is student like math. So, in order to build a bag of words model, the first step is always to determine the vocabularies. We will first define our own vocabularies, which is the collection of words found in the documents. From these two sentences, the unique words are student, learn, NLP, and like math. And the second step is to count the occurrence of each word appear in each of the sentences. After that, you are able to construct a matrix called document term matrix, while each of the rows represent a sentence and each of the columns represent the words in our vocabularies. And the value in this matrix shows the occurrence or number of counts of each of the words in the sentences. So, the bag of words will process a sentence or document as a bag of words. Moreover, we are able to visualize the sentence vector in an n-dimensional space, while n equals to the number of unique words in the vocabularies. And this can also enable one thing, that we can calculate the similarities between different sentences. While we can calculate cosine similarities based on the angle between the sentence vector, or we can use Euclidean distance to calculate the similarity between sentences, or simply using the dot product to calculate the similarities. Let's discuss some pros and cons of using bag of words model to represent natural language. First of all, bag of words is very simple to understand and implement because it is just counting the number of unique words in every sentence. However, bag of words has two major issues. Firstly, it has the curse of dimensionality issue as the total dimension equals to the vocabulary size. It can easily overfit your model. The remedy is to use some well-known dimensionality reduction technique applied on your input data. Secondly, bag of words representation doesn't consider the semantic relation between words. Generally, The neighbor words in a sentence should be useful for predicting your target word. You can search Word2Vec skipgram model for more details. Word2Vec language model is very popular in current years in the domain of natural language processing, and its central idea has extended to graph analysis, such as graph embedding.